Hey everybody, so OpenAI released a paper today, and I saw it in the news, and the very first thing that I want to clear up is how I heard this article described. So in the news article that I read about this particular paper, they described it as OpenAI making the claim that they have solved for AI hallucinations or are working to solve it with this paper. Having read the paper, that's not what the paper is at all. So I'm not positive if that discrepancy is on the OpenAI side or just on the news reporting side, but just pointing that out up front, that if you hear those types of claims about this paper, that's not what the paper says. And then kind of just illustrating this a step further before we dive directly into the paper. This is the website hosted by Cornell University, archive.org, so arxiv.org. And then any sort of papers that are academically related and related towards artificial intelligence are hosted on this website. And then as you can see, there's 721 entries on this website in the last 5 days. So that breaks down to around 150 articles per day. And so you can see that with all of these submissions per day, no one would ever review 150 articles per day. No one could review 150 articles per day. So if this article had come out today and it weren't written by OpenAI, I wouldn't be reviewing this article. There would be no point to. There's 125 articles per day that come out that are potentially more significant than this article. But since this article is written by OpenAI, the news is picking up on it, we have to talk about it. So the paper is called Let's Verify Step by Step, and it's written by OpenAI and OpenAI employees. Diving into the paper itself, it's pretty straightforward. Up front, again, they don't make any sort of claims, direct claims whatsoever, anywhere in this paper, not in the entirety of it, that they're solving for or eliminating AI hallucinations, and we'll go into the numbers here in a bit. But so the basic overall gist of this paper is very straightforward. So currently right now within the status quo, there's it's called outcome supervised reward models, which is when you're training a model, you train it off of the outcomes that it provides. And then so if it's you give it a bunch of questions to answer, and then if it answers them wrong, then you say, hey, that's a wrong answer. And then so it understands between right and wrong answers in that sense. And then that's kind of just what supervised training is on it in a nutshell, like a really distilled format. And then so what this paper provides for and what it recommends is an approach called process supervised reward models. So essentially you're looking at the process as opposed to the outcome. And which in itself is I think that it deserves a paper, and this would be a concept that would be incorporated within AI training, and it has been incorporated a lot more into AI training and getting better and more efficient and proficient at the training process, and then realizing that the training process is everything, that the data, making sure that the data is extremely clean, extremely unbiased, every single thing that you can do within that training process. And then so this is just kind of like another iteration of that. And then so process supervised reward models in a nutshell is just saying that if we have a large complex problem, let's say in this instance a large complex mathematical problem, rather than looking at it holistically and then rewarding or not rewarding the holistic outcome, let's look at the problem in pieces. Let's look at it in piece 1, 2, 3, 4, and 5. And then so if it fails at process 3, then we can say, hey, you're doing a good job on process 1 and 2, but process 3, we need to do work there. And then it's a better training model. The downside to this particular training model is that as of right now, there's no way to automate that training, whereas with outcome-based training, AI can essentially train itself on outcome-based training and go through, and it's completely automated. Whereas with this process-supervised approach, you have to have human intervention during the training process. So it's a lot more intensive of a training process. And then when you look at the methods and then the scope and then everything that they lay out within the methods, the bottom line is that this model is only, what they're doing is they built out a math model, and it's only applicable to math problems and math equations. And then this model did show significant gains on math problems. And there's really, if you break down the paper, there's two things in here that they do. The first one is that process-based approach, where they break it large complex problems down into simpler problems and then evaluate the process one step at a time. And then the second thing is that they immediately start training the model on like very hard data sets of math. So instead of working up from the easiest data sets and the easiest problems, it immediately up front throws like hard problems, and then it's let's start the training at a very high level, and then go from there. And then that seems to, so what we can see from the results of this is we can see some gains and some gains across the board. One thing I don't like about this paper at all is that a lot of them don't give, they're not giving like full benchmarks and benchmarks against other models or anything like that. This is just one model. So this paper academically is going to get ripped apart, hands down. But I think a lot of people will be in the same boat as me, where they're talking about this paper because everyone is talking about this paper because it's written by OpenAI. So in this particular graph that we're showing here, they show about 6% gains, which is pretty good. And then across the board, what you can see is like looking at these and then looking at the different subjects, in general, about like a 5 to 10% if you average it out. Some have like a significantly more than that. So then when you average down, I think it's to about like in that 5 to 10% range. But while that's good, and so that's good overall, and then these are again good things overall. But I mean, to me, these types of papers and these types of gains are what, there's 150 papers per day that aren't written by OpenAI on these types of things. Like, read this paper holistically, there's not much as far as academic quality, as far as what is the actual output of this paper. The other thing to note is that they don't release the model at all, any of the weights, any of the data behind the weights. The data that they give at the end, so every paper after the conclusion, if you scroll past it, there'll be the essentially a breakdown of the data and more in depth. They cherry pick every single part of the data and only give very specific examples. And then whether that's, no matter what the argument is, if it's examining true positives, it's cherry picked examples, and they say it's cherry picked examples. If it's true negatives, the same thing. There's 4 examples, and they trained it on hundreds of thousands of pieces of data. So there's a lot of questions overall as to the validity of this paper. If it weren't written by OpenAI, no one would be talking about it. I don't think that the academic community is, and I'm not speaking for the academic community, but I don't think that the academic community is going to find much interest in this. I don't think it lays out anything that we don't know. I think the academic community has also been, if you read other papers, this process-based approach and everything with regards towards the process is things that we already know. But overall, they do give their method. They do give some data in support of the method. And bottom line, if you take extreme attention towards the training process and all of that involved, that's what matters to your model the most, and you will see some gains out of it. So that's what this paper shows. I hope everyone likes this video. If you like this kind of content, please like and subscribe. Thank you very much.